Hello everyone, today we are going to talk about our integument, which is our skin. Our skin is actually our largest organ, and it's considered an organ because it's made up of multiple different types of tissues. For our skin, we have two layers. We've got that upper layer right here, known as our epidermis. So this whole entire layer is the epidermis. And then we have the dermis, which is that layer right here in the middle. The hypodermis, hypo means below. You can either call it your hypodermis or subcutaneous. Cutaneous meaning skin, sub meaning below. We don't really consider the subcutaneous or the hypodermis to be part of our skin. So the skin is only made up of the epidermis and the dermis layer. The epidermis is made out of stratified squamous epithelial tissue. The dermis is made up of connective tissue, and we're going to talk about it in more detail. The hypodermis down there, it's made up of mostly adipose tissue, which is mostly fat tissue. The dermis is made up of two layers. You have that upper portion known as the papillary layer, and most of the dermis is actually this layer right here known as the reticular layer. We're going to talk about some of the glands and their names. So we have the oil glands known as sebaceous glands. And we're also going to talk about our sweat glands known as sudoriferous glands. Now, when we think of our skin, we think of our skin protecting our insides. So your skin is basically a protective layer that you have, protecting you from so many different things, protecting you from pathogens trying to get inside of your body, protecting you from harmful sun rays, protecting you from losing water. And so therefore, when individuals, let's say they burn themselves and they lose their skin, one major problem they're going to face is actually dehydration, because your skin is actually preventing you from losing water. Your skin can help you regulate your temperature since we have the sweat glands. So let's say you get too hot, your sweat glands are going to be activated and you're going to sweat to cool you off. Your skin definitely has sensory receptors, touch, pain, pressure. So we have all of these different receptors that can help us feel different sensations. We can definitely excrete waste through our skin. So we can excrete sweat, for example, which is going to carry some waste out of your body via the sweat ducts. So those are really some important functions when it comes to our skin. So let's go ahead and now take a look at the layers of our skin. So we're going to start off with our epidermis. Epi, by the way, means above. So this layer is above the dermis. That's why we call it epidermis. Your epidermis, it's avascular, meaning that it does not have any blood vessels. And so right here, this is a histology image. Notice that there are no blood vessels because your epidermis has 0 blood vessels. Now, if it doesn't have any blood vessels, if your epidermis doesn't have any blood vessels, where is it getting its nutrition from? It's getting its nutrition from the layer below it, which is the dermis. The dermis does have blood vessels, and those blood vessels, they're carrying nutrients. And so the nutrients diffuse from the dermis up to the epidermis. And so that's how the epidermis can get its nutrition that it needs. Now, the epidermis, it's made out of stratified meaning you have multiple layers, squamous epithelial tissue. And so the layers from the bottom to the top, you would have the stratum basale. That's going to be the the most deepest layer. Below it would be the dermis. So the deepest layer of the epidermis would be the stratum basale. Then you would have the stratum spinosum. Then you have stratum granulosum, stratum lucidum, and stratum corneum all the way up to the top. Now, let's go ahead and start talking about our stratum basale first. The stratum basale is made up of just one single layer of cells, so it's just one layer of tissue. The stratum basale has very active mitotic cells, meaning that the cells within your stratum basale, they are able to go through mitosis, which is basically cell division. Why is that important? Because every few days, you regenerate your skin. You shed off the old layer of skin that you have, and you have a new layer of skin. We shed off our skin and get a new layer every around 25 days. So every 25 days or so, we go ahead and get a new layer of skin. So which part of your epidermis is responsible for that regeneration process? It's the stratum basale. So the stratum basale the cells within the stratum basale, they're going to divide, and they actually differentiate, meaning that they turn themselves into cells known as keratinocytes. So you get those keratinocytes, and what happens is the keratinocytes, they are going to push themselves upwards. The more the cells push themselves upwards, we're going to talk about it, the more they're going to start dying, to the point that when the cells reach the very top, which is the stratum corneum, the cells are dead, meaning that they have no live organelles inside of them. They are just dead cells. But those dead cells are actually pretty strong, and we're going to talk about why they are pretty strong. So the stratum basale, this is where you're going to have, like, you know, the cells that will differentiate into the keratinocytes, and the keratinocytes are very strong. They produce a protein known as keratin, and the keratin protects us because it's a pretty strong protein, so it makes your skin more durable, able to withstand you know, the harsh environmental conditions that your skin is going to face. And keratin is also going to help waterproof your skin. So what else do we have within our stratum basale? We have cells known as melanocytes. Cyte meaning cell, melano coming from the term the pigment melanin. So melanocytes, those are the cells that are going to produce our pigment, the melanin pigment, which is brownish in color. It comes in different hues, by the way. And the melanin is going to help us actually give us protection against the harmful UV rays, and we're going to talk about how it does that. We could also actually have some tactile cells, and those tactile cells that we have are sensitive to touch. So those are like our sensory receptors. So as I said, the stratum basale, they are definitely, this layer is alive, and the cells are very much alive, and they're going to divide. And as I said, as they divide, they start to differentiate. They kind of turn themselves into those keratinocytes, and then those keratinocytes are going to start pushing themselves upwards. So the layer above the stratum basale, we have our stratum spinosum. The stratum spinosum is actually made up of several layers. So it's several layers thick, and those, as I said, like, you have now your cells that are differentiating into those keratinocytes, and the cells are still alive. So the cells within your stratum spinosum, they are still alive. Within the stratum spinosum, we could actually have some cells that can help us fight off infections. We call them phagocytes. So phagocytes are cells that would help us fight off infections. So let me just write down that term for you. So whenever you guys see the term phagocytes, that would mean You can either call them phagocytes, by the way, and one type of a phagocyte that we have within our stratum spinosum, those are called dendritic cells. So dendritic cells are a type of phagocytes, and whenever you see the term phagocytes, that means that those cells to help you out, to like fight off infections, or to help you basically protect you against any foreign particles you might have. What they do is they engulf that foreign object. So the phagocytes or the dendritic cells, what they do is they go ahead and they swallow the foreign particles. So any toxin like bacteria, they go ahead and they actually swallow it whole, and then after they swallow it, they digest it within them, and that's how they can protect us. Now, above the stratum spinosum, we actually have our stratum granulosum. So the stratum granulosum, it's made up of about 3 or 5 layers, and again, we're going to call the cells there the keratinocytes. And now the cells, they're producing even more and more keratin within them. And once we reach the stratum granulosum, the cells start to die, meaning that the organelles that are found within your cells, those organelles, they start to degrade and they start to break down. The cells are still not completely dead, but they are beginning to, they're starting to die because those organelles are dying. So the cells are losing their organelles, but the cells are being filled up with the protein keratin. And as I said, keratin is a pretty strong protein. So even though you're losing, like those cells are losing their organelles, those cells are still pretty strong because they're being filled up with that strong keratin protein. Above the stratum granulosum, we have stratum lucidum. Stratum lucidum is pretty special because you only have it in thick skin. Meaning that layers of your like skin layers that we call thin skin would not have stratum lucidum. So where do you have thick versus thin skin? Your thick skin that's going to have the stratum lucidum is basically like the palms of your hands, your fingers, again like the base part. This would have thick skin. Your sole of your feet, you would have thick skin. Everywhere else is considered thin skin. So if, for example, you talk about your forearm or your arm or your eyelids, all of that would be considered thin skin, and you wouldn't have the stratum lucidum. Stratum lucidum, as I said, you would only find it where you have only present in thick skin, like palms of your hands and soles of your feet. And the cells right here within the stratum lucidum have no organelles. So all the organelles are dead. The stratum corneum, that's the most superficial part of our epidermis, and it's pretty thick. You have about 20 to 30 layers within your stratum corneum. Again, its thickness depends on which part of the body we are talking about. So, of course, your eyelids versus your arm, right? The amount of layers of your stratum corneum is definitely going to vary. The stratum corneum, the cells within the stratum corneum, they are dead cells. So no organelles within those cells. Those cells are now just filled up with the protein keratin. And as I said, the protein keratin is pretty strong, and it gives durability to your skin, and it makes your skin basically tough to be able to withstand the harsh environmental conditions that it's going to face. The stratum corneum is the layer that we slough off by abrasion, or for example when we get burnt, or when we're just, as I said, like shedding our skin normally. That's the layer we are shedding off, the stratum corneum. They actually say that throughout our lifetime, we are going to shed about 40 pounds of stratum corneum. That's a lot. So that's what we shed off. And again, it doesn't hurt when you shed off your stratum corneum because the cells are dead. So again, it doesn't hurt at all. And that's why we say that the cells there are dead, dead keratinocytes. And as I said, every 25 days we go ahead and we create a new layer of skin, and it all comes from the stratum basale. The cells would divide and they would keep pushing themselves upwards. By the time the cells reach the stratum corneum, they are going to be dead because the organelles start dying, kind of like right here, they start dying, and by the time your cells reach up at the top, they are already dead. So these are the epidermal strata layers that we have. We talked about the keratinocytes, we talked about melanocytes. Those are the ones that are responsible for producing your melanin pigment and giving you pigmentation to your skin. We talked about how we have dendritic cells, and another name for them are phagocytes, or they are a type of phagocytes. We talked about tactile cells. Another name actually for tactile cells, let me also give you that other name. Tactile cells, those are your touch receptor cells. You could either call them tactile or you can call them same thing as calling them Merkel cells. So Merkel cells or tactile cells, those are the same type of cells. We talked about the thick skin versus thin, and as we said, thick skin, you're going to have all 5 layers, so including the stratum lucidum. When we talk about thin skin and you remove that stratum lucidum, we only have 4 layers for our thin skin. So that's just kind of showing you histology images of the thick skin versus the thin skin. And again, you notice that with the thin skin, you are missing the stratum lucidum. Whether we are talking about thin skin or thick skin, it's still epithelial tissue, and epithelial tissue is going to be avascular. So again, no blood vessels within your epidermal strata layers, whether we're talking about thick or thin, again, it's still avascular. Now, our skin color, if we talk about our skin color, the most important, like really pigment that's responsible for giving you your skin color is your melanin. So your melanin, again, it's the pigment that's produced by your melanocytes. The reason why different individuals have different hues for their skin color is it depends how much melanin you are producing. So the more melanin you produce, the darker your skin color would be. The less melanin you are producing, the lighter your skin color would be. Individuals that don't produce any melanin, so their melanin production is extremely low or they don't even produce any, we refer to that as albinism. So albino individuals, they don't produce melanin, and so that's why they are very, very fair in color. And melanin doesn't only give you your skin color, but melanin also helps you. It also gives color to your eyes and to your hair as well. And again, that's why with albinism, the hair would be just white because again, they're not producing melanin. Hemoglobin is actually the protein that helps transport oxygen. So hemoglobin is a protein found in your red blood cells. With individuals that are pretty fair and they don't produce enough melanin, you can actually kind of see the hemoglobin color because the hemoglobin color is reddish in color. So you would find that their skin color has kind of like a pinkish hue to it. Because of the hemoglobin that you're seeing. Carotene is actually like a yellowish orangish pigment, and it can can actually accumulate within your stratum corneum. And so one thing you would notice is that, especially with babies, if you feed babies a lot of carrots, which has the carotene, your baby's skin color could actually turn a bit yellowish, orangish, and that's just because the carotene is accumulating within their skin, and they're still having a hard time breaking it down, and so yeah, they could turn actually yellowish, orangish. Now, why, when we get exposed to a lot of sun, we tend to tan? The thing is, melanin, right here, so those are your melanocytes, and melanocytes produce the melanin pigment, as I said, and the melanin pigment kind of accumulates in granules, and the melanin, kind of like you have here, like vesicles. You can think of a vesicle as a pouch. So basically you get those pouches, and those pouches, they fill up with melanin, and those vesicles, or you can think of them as pouches, as I said, they start to surround the DNA within your cells. And it turns out that melanin is actually a natural sun protectant, protecting your DNA from the harmful UV rays. And that's why you would notice that when you get exposed to a lot of UV rays, basically, or sun rays, you would notice that your skin gets darker. And the reason why it gets darker, because your body starts producing more melanin to protect your DNA. Because UV rays can penetrate, so the UV rays can penetrate your cells, and they can actually start messing up your DNA, and they can start causing cancer. So when someone gets melanoma, skin cancer, one reason is that they were exposed to, throughout their lifetime, they were exposed to a lot of UV rays, and some of those harmful UV rays started to mess up their DNA. And so that's why, again, your skin gets darker when you're exposed to a lot of sun rays. Now, that's why we say to always kind of try to do your best to protect yourself from those harmful UV rays, and put sunscreen. Even if your skin is a bit darker in color, you still need to protect yourself, and you still need to put sunscreen. Some individuals, especially those who don't produce enough, a lot of melanin in the first place, they would have a hard time actually getting a tan because they're not producing enough melanin. So they would notice that when they get exposed to a lot of sun, they just turn red and they don't get the tan because their body's not producing enough melanin in the first place. And again, those individuals would have to be even more careful and protectant about their skin so that they don't develop skin cancer. Some of the skin markings that we have, we usually, call it a mole. Its anatomical name is a nevus, and that's basically overgrowth of melanocytes. So if you have a bunch of melanocytes that kind of accumulate together, that's basically what a mole is. That's different than freckles. Freckles is accumulation of the pigment melanin. So freckles is just you have areas that are containing more melanin pigment, and that's basically what freckles are. Friction ridges, that's a fancy name for saying fingerprints. So friction ridges are basically your fingerprints, and you get fingerprints because when your epidermis, which is that top layer of your skin, kind of folds, the bottom part of your epidermis, where you have your stratum basale. I'm going to show you a picture of it, but it's kind of wavy. And so when you have the epidermis merging with your dermis layer, we kind of have those waves. I'm going to show them to you, and those waves, that's what determines your fingerprints. Identical twins don't even have the same friction ridges, so identical twins don't have the same fingerprints. which tells you that your DNA has nothing to do with determining your fingerprints. It's just that when you are developing, how your skin kind of folds, and depending on how it folds, that's how you get your fingerprints. There are actually individuals out there that do not have fingerprints. Why do we need fingerprints? Fingerprints are just going to help you increase the friction for you to grasp better. So you would notice fingerprints on, of course, like, your fingers and your toes, and just kind of, helps you grasp things better. Now, why is it when you hold a glass of water, or any glass really, you notice that you leave your fingerprint mark? What are you really leaving behind? What you're really leaving behind is basically sweat and some dead skin cells. That's what you're leaving behind. And that's when we say, oh, you left your fingerprint on that glass. So this is kind of what I was talking to you about. So see how here the stratum basale, see how it's wavy? And again, see how that top part of your dermis is also wavy. So again, those those waves right here, and we call these, by the way, like these mountains of the dermis, we call them dermal papilla. And again, this is this is what's going to help you get those fingerprints. Now, actually, it's pretty good that your epidermis and your dermis, they look the way they do, and they are kind of, notice how they interlock together? That's way better than having that bottom part of your epidermis completely flat and your dermis, that top part of your dermis, completely flat. Because the thing is, if they are both flat and they don't kind of interlock like this, it would be way easier for your epidermis and your dermis to actually separate from each other. Versus when they interlock like this, they are, they're tightly attached to each other. Now, I'm pretty sure, your epidermis and your dermis have detached at one point in your lifetime. If you've ever, if your skin has ever experienced a lot of friction, let's say you've put on new shoes and they don't really fit quite, they're not really the proper size, and the bottom of the shoe or the back of the shoe keeps rubbing against your ankle, you would notice that you would start getting a blister. Now, what is a blister? A blister is actually your epidermis right here and your dermis. Guess what? They've detached. And so when they detach, you get a blister. And that blister is usually filled up with fluid. Don't pop it, by the way, okay? That's dangerous. Just kind of leave it. Your body's just going to absorb the fluid on its own, because if you're tempted and you pop it, and let's say the needle that you've used to pop it was not really clean, then you can actually cause a huge infection, which can lead to, major problems, and you can go into a septic shock. And there have been cases of individuals infecting themselves when they try to pop their blister. So one more time, a blister is just your epidermis and your dermis layers have detached due to the high friction that your skin was experiencing. Burns can also cause blisters. So when you burn yourself, you can have a blister. And again, it's telling you that you've detached your epidermis and your dermis layers. Now, a blister is different than a callus or a corn. So a callus and a corn, that's usually due to your skin experiencing a lot of pressure. So a lot of pressure placed on your skin is actually going to cause your epidermis layers to thicken. Corns, we usually refer to it as corns if it's on your toes, calluses if it's on your fingers. And so you would notice that, for example, individuals that carry heavy weights, okay, they're always, let's say, training with their dumbbells, you would notice that they would have calluses on their palm of their hand because, again, due to carrying those heavy dumbbells and training all the time, they're putting a lot of pressure on that part of their skin. And so a lot of pressure on your skin is going to lead to calluses um, on your hands. So that's really, two things that we normally face, calluses and blisters. Right here, you see that your dermis, you can see blood vessels because your dermis is made out of connective tissue and it has blood vessels. And as I said, the nutrients within the blood vessels of your dermis can actually diffuse up to the epidermis. The dermis is made up of connective tissue, both areolar connective tissue and dense irregular connective tissue. There are two layers. This is the most superficial part of your dermis right here, known as the papillary layer. And the papillary layer, it's made out of areolar connective tissue. The top part of the papillary layer has those kind of ridges, mountain kind of hills looking like structures known as the dermal papilla. And again, it helps kind of interlock with your epidermal ridges right there. Your papillary layer does have blood vessels. You can see the blood vessels right there. Your reticular layer, that's the deepest part of the dermis, and it's made out of dense, irregular connective tissue. It does have blood vessels, and you see within the dermis, you have the hair follicles right here. You can see the sweat glands. You have the sensory tactile receptors. You also have, those are the sebaceous or the oil glands right there. The reticular layer of your dermis also has a bunch of collagen fibers and elastic fibers. Having good amount of collagen fibers and elastic fibers are going to not just give strength, like collagen fibers are pretty strong, so they can make your dermis, again, more durable, but it's also going to make your skin look younger. So as we age, we actually start losing our collagen fibers and our elastic fibers, and that's why you would notice that as someone ages, you would start noticing some wrinkles or your skin would start sagging. That's because you're losing those collagen and elastic fibers. Other factors could actually help you lose them faster, and that would be smoking and like being exposed to a lot of UV rays. So the UV rays can also damage those fibers faster for you. Let's see, the subcutaneous layer, as I said, it's below the dermis, so you can refer to it as hypodermis, and it's mostly made out of adipose tissue, which is fat tissue, and you also have some areolar connective tissue as well within your hypodermis. Having fat underneath your skin is actually a good insulation, like thermal insulation layer. And it also helps you store fat, which is good, like, good storage for energy. The fat, you can break it down and get energy out of it. And it also, like, having some fat underneath your skin, by the way, kind of gives your skin also a more younger look to it. And as I said, it's thermal insulation. That's why you would notice older individuals, their skin tends to become very thin because they are actually losing most of the fat in their subcutaneous layer. And that's why, again, older individuals would tend to feel colder faster because they're losing that fat in their subcutaneous layer. Within our dermis, as I said, we have those collagen fibers, and each part of your body, the collagen fibers are actually oriented differently. So you can see right here within the chest region, the collagen fibers are actually oriented kind of horizontally, and so the spaces between the collagen fibers kind of leave like a pattern behind, and that's the pattern that you are seeing, and we call it the lines of cleavage. Now, those lines of cleavage are really important when it comes to plastic surgeons, especially. So they don't want to, like, plastic surgeons, they don't want to leave you with a scar. So they want to actually give you less scars and kind of fix whatever scars you might have. And so the cleavage lines, the pattern of the cleavage lines for them is very important, because to have less scarring, you do not want to cut against the cleavage lines. You actually want to, so not to cut across it, but you want to cut along it. So especially if someone, let's say, has a heart attack, right? So if someone's having a heart attack and they need to crack their chest open, they're just going to cut longitudinal. But the thing is, if they cut longitudinal, check out the cleavage lines in your chest area. It's going horizontal. And so if you cut across it, as I said, like in this case longitudinally, you're going to have a scar. And so individuals that have a heart attack, they usually tend to have that scar for so many years, because it is a deep scar, and you did cut across those cleavage lines instead of going along it. If you do cut along it, then you are going to have less scarring. And so you can see that each part of our body, we actually have those cleavage lines. We have different patterns of those cleavage lines throughout our body. When someone develops stretch marks, or we call them striae, that's due to the collagen fibers within the dermis being overstretched or actually tearing and leaving behind those marks on your skin. One reason could be let's say someone put on some weight, and so your skin got a stretch to accommodate that extra weight, and so the collagen fibers would start to tear. As I said, another thing that can cause your collagen fibers and your elastic fibers to tear is being exposed to too much UV rays, and that can that can cause your skin to lose its flexibility, especially if you're losing a lot of those elastic fibers, and that can lead to wrinkling. The glands that we have within our dermis, we have sweat glands and we have sebaceous glands. The term for sweat glands, we use that term right here, sudoriferous, and sebaceous, it's basically your oil glands. Your sweat glands, so we actually have two types of sweat glands, Merocrine and Epidermis. So let's go ahead and talk about the sweat glands first. So your Merocrine sweat glands, you can actually either call them Merocrine, by the way, or there's another name. Let me write it down for you. So Merocrine, or you can call it Exocrine. So Merocrine or Exocrine, that's the same name. So you can either call it Merocrine or you can call it Exocrine sweat glands. And those are the most common, by the way. Those are the most common type of sweat glands that we have. Especially we have a whole lot of them on the palms of your hands and the sole of your feet. That's why some individuals, depending on how much sweat they produce, they would have very sweaty hands because their sweat production is pretty high. If actually someone has a problem with how much sweat they actually produce, one thing, it could be genetics, and another thing, it could actually be low vitamin D. So it turns out that low vitamin D can actually also increase the amount of sweat you produce. So someone would check like their vitamin D levels to see if everything is normal. If it's pretty low, that could be a reason why their sweat production is pretty high. The Merocrine sweat is like those sweat glands, the sweat that gets secreted out, it's mostly water, so it's like 99% water, and it's like clear. Now, why do we sweat? Sweat is going to help us regulate our temperature, so if you're really hot and you sweat, and there's a breeze of air, then that sweat can actually evaporate, and that's how we cool off. It's a way for us to secrete some of the waste out of our body. And it's also protecting us, as I said, like, you are going to excrete waste out of your body. You're going to regulate your body temperature so that you don't overheat. Uh, so the Merocrine sweat glands, again, those are the most common sweat glands that we have. The apocrine sweat glands, those are found in areas like your armpits, like around the nipple region, the groin area, the anal region. Now, the apocrine sweat glands, the secretion is a bit more thick and cloudier because it has like more proteins and lipids. And if you notice, like, when someone develops body odor, uh, it's usually like regions like your armpits that would kind of be the smelly part of your body versus your arm, right? So no one usually has a smelly arm, but they could have a smelly armpit. And the reason is because the armpit is where you have those apocrine sweat glands, which usually secrete like lipids, which is fat and proteins. And the thing is, we have bacteria living on us. So we have bacteria living on our skin. It has nothing to do with your hygiene, by the way. Like everyone, no matter how many times you take a shower, you have bacteria living on your skin. And so those bacteria, what they do is they start eating the sweat. So sweat normally doesn't smell. It doesn't smell. What makes it smell and the person would start developing the body odor is the bacteria eating the sweat, like eating, the proteins and the lipids. And because those proteins and lipids are usually produced by your apocrine sweat glands, like in your armpits and the other regions, those would be the regions that would develop the body odor. Our sebaceous glands are our oil glands, and oil glands produce sebum, which is the oil. And the sebaceous glands are usually kind of attached to the hair follicles, so the oil would be secreted into the hair follicle, and through the duct, it would actually be produced and secreted onto your skin surface. It prevents drying of your hair, by the way, and your skin. So when you have very dry skin or very dry hair, it could be that you're not producing enough oil. Another thing is that a common mistake someone would do is, let's say someone actually has pretty oily skin. They think that the more they wash their face and the more they make their face dry, the less oil they will produce. And it could actually be the very opposite. When your skin feels that it's very dry because you're washing it, let's say, all the time, the more your body's actually going to produce more oil because it's trying to protect your skin from drying out. Usually our sebaceous glands, they activate when we hit puberty. And so that's why you would notice that, when like, children start to, they're developing and they hit their adolescence years, so they're teenagers, that's when their sebaceous glands would actually start to be very active. And that's why we would notice that, like, some teenagers, they start developing acne. Why is it children don't develop acne all of a sudden when they're teenagers they start developing acne? That's because that's when your sebaceous glands are mostly active. What activates them are the sex hormones. So the estrogen and the testosterone, those sex hormones being released during puberty, that's what activates those sebaceous glands. And the sebaceous glands could end up producing like too much oil, and production of too much oil could actually start to block your sebaceous ducts. And so when those ducts get clogged up because of the too much oil, that can cause your skin to start getting inflamed, etc. And that's what's going to lead to the acne problem. And of course, like, when the ducts get also clogged up with all of that oil, and it could also get clogged up with like some dead skin, again, adds to the problem of inflammation and leads to acne. So right here, let me kind of show you if we have a skin model, those would be the sweat glands. And as I said, we have the two types of sweat glands, Merocrine, which is our most common, and then Apocrine sweat glands. The Epidermal sweat glands would be the ones, as I said, like armpit regions, etc. Here is, here's the hair root and like the follicle, and you can see that connected to it, you have the sebaceous glands, which are the oil glands. And so again, those oil glands, they usually release the oil, which is a good lubricative media for your hair, and it good also lubrication for your skin to prevent your skin from drying out.